Why don't bridges just collapse? Every day, millions of people cross bridges, on foot, by car, by train, and hardly ever stop to think about them. They stretch across rivers, valleys, and even oceans. But when you really think about it, isn't it kind of wild that they don't just fall? Bridges carry thousands of tons of weight constantly, so why don't they collapse? It all comes down to one thing: balance. When a car drives over a bridge, its weight creates a force that pushes down, what engineers call a load. But that force doesn't just sit there. The bridge is designed to transfer it. That downward force travels through the structure, into beams, cables, and supports, and eventually into the ground. Different bridges handle this force in different ways. A simple beam bridge relies on horizontal beams resting on vertical supports. These beams experience bending. The top gets squished and the bottom stretches. If they're not strong enough, the bridge would sag and fail. Now, take a suspension bridge, like the Golden Gate in San Francisco. These are incredible feats of engineering. Thick steel cables stretch between two tall towers. The road hangs from those cables like a hammock. Here, the cables handle pulling forces, what engineers call tension, while the towers and anchors absorb the pressure. It's a delicate, invisible tug-of-war between forces pulling and pushing. If it's perfectly balanced, the bridge stays standing. But what happens when that balance is off? In 1940, the Tacoma Narrows Bridge in Washington state twisted itself to pieces in the wind. It wasn't built to withstand aerodynamic forces. The result? A spectacular collapse. One of the most famous engineering lessons in history. Since then, engineers have made bridges smarter and safer. They now account for wind, earthquakes, and temperature changes. They test for material fatigue and build in safety factors, backups in case something goes wrong. Today's bridges are more than just concrete and steel. They're living designs, flexible, responsive, and incredibly strong. They're built not just to carry cars, but to stand the test of time. So the next time you cross a bridge, take a moment. You're not just driving over empty space. You're riding on a masterpiece of engineering, one that's doing a lot more than meets the eye. And this is just the beginning. If you want to know how skyscrapers survive earthquakes, how tunnels are built under oceans, or how cities float on water, stick around. Subscribe and join us as we uncover how the modern world stands tall.